All right, we are working through this booklet of quadrilaterals as a review of sections 6.2, 6.3, 6.5, and 6.6. So you guys should all have your booklets in front of you. We do need you to go ahead and complete the blanks here and add the markings on your figure to show that opposite sides are congruent, opposite sides are parallel, opposite sides are angles are congruent, sorry. Consecutive angles are supplementary and diagonals bisect each other. Notice that this is a review of what's already on your purple sheets, but we wanted you to have everything in one place instead of having to flip back and forth between all of those purple sheets. So this is for parallelograms. So pause this and try working through these examples below. Once you are finished, then unpause it and check it to see how you did. All right, so this says if ABCD is a parallelogram, the measure of angle A is x and the measure of angle D is 2x minus 3, then find the value of x. Okay, so this is making an assumption that you know whether these are opposite angles or adjacent angles. So if I label this ABCD, if I'm just walking around it like it's listed, and this is the measure of angle A is x and the measure of angle D is 2x minus 3, then they are landing as consecutive angles, so they should be supplementary. So setting this up, they would add up to 180. X plus 2x minus 3 equals 180. Combining like terms, I have 3x minus 3 equals 180. Adding 3 to both sides, I have 3x equals 183. And then dividing both sides by 3, 61. That sound right? Okay, then find the value of x, that's all they want. There we go. Okay, so example 2 says that WXZ, WY, XY, goodness. Okay, so I'm just going to draw it. And again, it's making assumptions that you're going to walk just around the parallelogram like it says. X, Y, Z, W. This parallelogram with diagonals, XZ. Oh, okay, well at least it tells you here so that you know. XZ and YW that intersect at point A. So there is the diagram based on the information that they're giving us here. And it says if XA is 3M, so I'm labeling this 3M, and ZA is 5M minus 4, then find M. So in a parallelogram, the diagonals bisect each other, which means that these two segments are going to be equal to each other. And sorry, this is a little blurry. I'm going to close it in a little bit. All right, so we have 3M equals 5m minus 4. I want to move my m's to one side, so I'm going to subtract 5m from both sides. Gives me negative 2m equals negative 4. Then dividing both sides by negative 2. I've got that m equals a positive 2. Concur? All right? All right, then example 3, they gave us a figure. That was nice, okay? So we're on the parallelograms page, so we know that the opposite angles are congruent, so we know that angle Z is also 120 degrees. Okay? So we can, well, we could do a couple of different things here. We could use our triangle sum theorem to find this one up here, or we could use the fact that because it's a parallelogram, we have alternate interior angles here that are congruent. So presuming that's a 5, if this angle is 35, then y is also 35. Okay. Then I'm using triangle sum theorem and adding up the two I have and subtracting them from 180. So I'll have 180 minus 155, which gives me 25. All right. Okay, so far. We are a sixth of the way done. Rectangles. The next flap here, and if you guys need more time, and obviously you will because I've already done this and y'all are going to need to write these as neatly as you possibly can because this is your resource for the test. You're creating your own cheat sheet here, so please make sure that you can read your writing and that you're doing your best. But these are the rectangle. Make sure that you fill in the blanks here and make markings on the figure to indicate that opposite sides are congruent, opposite sides are parallel, opposite angles are congruent. Consecutive angles are supplementary, diagonals bisect each other, there are 4 right angles and diagonals are congruent. Again, pause it so that you can get all this information. While you have it paused, go ahead and try the 3 practice problems and don't unpause it again until you're ready to check them and see how you're doing. Okay, so example 1 says quadrilateral RSTU is a rectangle with diagonals that intersect at P. sketching it out, I have quadrilateral RSTU with diagonals that intersect at P. Wow, that's a bad rectangle. Okay, this says if angle RSU is 3x minus 5, so since it's so tiny, I'm going to have to draw an arrow, and angle UST is 4x plus 4, so that's going to be this angle right there. Then find the value of x. Well, these two angles together, and you can tell because they both have s's in the middle, they're going to create one of the 90-degree angles at the corner. So both of these are going to add up to 90. So we've got 3x minus 5 plus 4x plus 4 equals 90. Solving for x, I have 7 x's, and then I have negative 5 plus 4, which is negative 1, equals 90. And then I'm adding 1 to both sides. So I've got 7x equals 91. So x equals 13. All right. Okay, example 2. Quadrilateral. ABCD is a rectangle with diagonals that intersect at point P. AC and DP, I'm going to have to draw this one also. Try to do a scotch better so it looks a little bit, oops, I already messed that one up, goodness. A, B, C, D. Okay. Sorry I'm going so fast, it's late. I'm going to go home some point. We have AC, that's 4x minus 3, and DP is x plus 7. Okay, so what we have here is a portion of a diagonal and an entire diagonal. Okay, so based on how the diagonals behave in a rectangle, we know that x plus 7 is half of 4x minus 3. So that we don't have to play with fractions, let's say that 2x plus 7s equals a 4x minus 13. Okay? Then I can just distribute and solve for x. Distributing here, I have 2x plus 14 equals 4x minus 13. Combining my like terms across the equal sign, I'm subtracting 2x from both sides and adding 13 to both sides. So I get that 2x equals 27. Alright, so dividing both sides by 2, I get 2702, which is a perfectly valid answer, but if you want to change it to a decimal, you can, and you should get 13.5. Okay? Alright, here we have example 3, and we have quad JKLM. Sketching. JKLM is a rectangle with diagonals, showing diagonals that intersect at point P. They like point P. LP is 3x plus 7, and MK, again, the entire diagonal, is 26. Find the value of x. Okay, so again, you have 2 of the 3x plus 7s equaling 26, or you could say half of MK is 13. So you could just set 3x plus 7 equal to 13. That might be an easier way to go there. Either way would work though. So 3x plus 7 equals 13. I'm going to subtract 7 from each side, which is going to give me 3x equals 6. Dividing by 3 gives me that x equals 2. All right. 2/6 of the way done. Or a third. Okay. The rhombi, which is plural for rhombus. Again, please pause it so that you can see exactly what to put in the blanks and what to mark on the figure, and please do so neatly to indicate that the rhombi have opposite sides congruent, opposite sides parallel, opposite angles congruent, consecutive angles supplementary, diagonals bisecting each other. 4 congruent sides, diagonals that are perpendicular, and diagonals that bisect opposite angles. Keep it paused while you work through the 4 examples down here, and then unpause it when you're ready to check them. Okay, in example 1 here, it says that angle RST is 67, and it wants you to find angle RSW, which is just going to be half of it, because the diagonals bisect those angles. So all we need here is 67 divided by 2, which is going to give us 33.5 degrees. When you're finding an angle measure, it's degrees, every time. Okay, example 2 here, we have angle find angle SVT if angle STV is 135. Okay, so if all of this is 135 degrees, and we know that consecutive angles are supplementary, that what we want to do there? We want this one right here. We don't want this whole thing down here. What do you think?
You can do it about half.
You didn't divide them up because they're bisected?
Mm-hmm.
The diagonals bisect the opposite angles. Good, good, good. Thank you. Okay. All right, so if I find this whole angle down here, then I can just divide by 2. Thank you. Okay, so 180 minus the 135 gives me 45. And then I'm dividing that by 2 to give me 22.5 degrees. Oops, that looks like a Z. Good? Okay. Alright, so looking at example 3 here, we have angle SWT. SWT in the middle here. This is a rhombus, so that's going to be a right angle. The diagonals are perpendicular. So we know that angle 2x plus 8 equals 90. Okay? So we just need to solve for x here, so I'm going to subtract 8 from both sides, which is going to give me 82. Then dividing both sides by 2, I get 41. That just showed me something else I could have done in example 2. Knowing that this is a right angle here, I could have split 135 in half and just subtracted that from 90. Alright. Okay, so example 4 here says find the value of x if the measure of angle WRV, which is 5x plus 5, and the measure of angle WRS is 7x minus 19. Okay? And it wants me to solve for x here. Okay, so are these mimicked triangles going around? Because all of these sides are congruent. Which means that this would also be 7x minus 19, and those should add up to 90. Let's go with that. Alright, so we're going to say that 5x plus 5 plus 7x minus 19 equals 90. Okay? Alright. Then we're going to combine our like terms here and say that 12x minus 14 equals 90. Adding 14 to both sides, 12x equals 104. Dividing both sides by 12, I get that x is... Was it decimal? Did I go astray? We could have a decimal. What's the decimal?
8.666.
8.6 repeating? Yeah, I'm not entirely sure that's how they wanted that worked anyway, because that would make this a right angle. That would make it a square.
Yeah, well, I mean, since it's a rhombus, you know it's bisected the angles. So
Right.
you can set them equal to each other.
Oh, that's better. Okay.
If you do
So
that,
this
it'll
is
be
not how to
different.
work this, and I am not redoing this. You're just gonna. This is gonna have to be a teachers rank mistakes 2 situation. Okay. So since the angles are bisected, and you guys probably already had this because you had it paused while you were working these, so you probably know this anyway. So my apologies, but we are gonna set these equal to each other. I bet that's gonna give us a whole number. 7x minus 19 equals 5x plus 5. So subtracting 5x from both sides and adding 19 to both sides is going to give me 2x equals 24. So x equals 12. That's way better. We like 12 so much better on that one. Good? All right. We are 3/6 of the way done. Or half. So on the square, there are so many blanks here and so many qualities because the square is such a special, it's such a special shape. So make sure please that you fill these in very neatly and that you make markings on your figures accordingly. So opposite sides are congruent and parallel. Opposite angles are congruent, obviously, because they're all 90 degrees. Consecutive angles are supplementary, obviously, because 90 is 180. Diagonals bisect each other and they're perpendicular. There's 4 right angles, 4 congruent sides, diagonals are congruent, and they bisect the opposite angles. Pretty much every special situation you can have is present in the square. Okay, pause it, please. Work these problems while we work them, and then unpause it and see how you did versus your geometry teachers. Okay, example 1 says that angle AED, which hopefully you know is a right angle, is 5x plus 5, solve for x. So 5x plus 5 equals 90, so 5x equals 85, and x equals 17. All right. Okay. Example 2, we have the angle. Is that a square? Do you think they probably intended there to be a line here? Okay, we're going to go with that. It says that angle BAC, which hopefully you know is 45 degrees, because in a square, the diagonals cut the 90 degrees in half. So angle BAC is 5x, find x. So we have the 5x equals 45, and presuming you know your times tables, x is 9. Okay. All right, example 3 says that MH, oh goodness. Okay, it says that MH is 8. This is a square, all your sides are equal, and it wants the diagonal, which is the hypotenuse. Now, we haven't done special right triangles, so we can't go there with that, can we? But we can just do Pythagorean theorem. Special right triangles is so much easier. Y'all just wait, we're getting ready to do special right triangles. It's going to make your life so much easier in this. But for right now, 8 squared plus 8 squared equals c squared. 64 plus 64 equals c squared, or 128 equals c squared. So c is the square root of 128. Now we probably would go about this differently. I would not allow my students to give me a decimal answer. We would reduce the radical. Okay. So obviously we know when you reduce the radical, you're making a factor tree. Okay, so 128 is 2 times 64. Obviously we know that. 64 is 2 times 32. 32 is 2 times 16. 16 is 4 times 4, and you can break those down, or you can just use that pair. So after you've made your factor tree, you're pairing them up. I have a pair of 4s here, and I have a pair of 2s here. Remember that anytime you have a pair, they get to go on a date and leave the house. So I have a 2 leaving the house and a 4 leaving the house. This 2 doesn't have a date, so he has to stay at home. Okay? 2 times 4 is 8, so I end up with 8 root 2. Now, if you're not fluent with reducing radicals, then root 128 is not an incorrect answer, it's just not simplified. Okay? Or if you're going to punch it in and get a decimal, I suppose that's not entirely incorrect either, as long as you put an equals approximately symbol in front of it. Okay, in example 4, we're going to make the assumption that they intended for H and T to meet. Okay? This says that MS is 3, and that AS is 3. Okay? This wants you to find the perimeter of square math. Okay. So this is another situation where it would be a beautiful thing if you knew how to do special right triangles. 3 squared plus 3 squared equals side MA squared, because that's representing your hypotenuse here. So 9 plus 9 equals MA squared, so 18 equals MA squared. So MA is the square root of 18, which we obviously know is 9 times 2, and 9 is 3 times 3. So you have a pair of 3s here. They're going to go on a date and leave 2 home. So MA is 3 root 2. This being a square, all of the other sides also equal 3 root 2. So the perimeter is just 4 times 3 root 2, or 12 root 2. Root 2. Sorry that got a little messy. You're welcome to pause it and get all this down on your own paper. Please keep in mind that answers are 100% meaningless if you have no idea how you got them. So we are going to require work, not just answers. We are 4/6 of the way done. Trapezoids. Notice that there are 2 different sections on the trapezoid page, because the first one is just your garden variety trapezoid, and then you have isosceles trapezoids, which have all kinds of fun special features. Okay, so in your trapezoid you have exactly 1 pair of parallel sides, and then you have what they're calling a median. This is what we call a mid-segment in the Envision book. It's the same thing. The median or mid-segment connects the midpoints of the legs, and its length is 1/2 the sum of the bases, which is also true in the isosceles trapezoid, but you have all kinds of other special things here. You have 1 pair of parallel sides, same thing with the median. The legs are congruent, the diagonals are congruent, and the base angles are congruent. Don't forget, you've got 2 bases in a trapezoid, so you have 2 sets of base angles here. Okay? Alright, pause it. Put all of this down. I don't think I centered up on this at all. Here we go. Pause that. That says mid-segment. Pause that. Okay? So there's 4 examples down here that you will work while your computer's paused. And then you will unpause it and see how you did. Okay, so here we need to find the value of x. Since these are parallel lines, these are same side interior angles, which are supplementary. So I think that this says 12x plus 3, and that says 13x plus 2. Close enough, okay? We're going to add those up and set them equal to 180 because same side interior angles are supplementary. I have a total of 25x's here, plus 5 equals 180. So I have 25x equals 175. I'm going to think of money. How many quarters are in a buck 75? That's going to be 7. Okay. All right. Example 2. Here I have that AB is 7y plus 6. I have that EF is 5y minus 3. There was a problem very much like this on your homework. And DC is y minus 2, and I want you to find the value of y. So we know that the mid-segment is half of the sum. So 5y minus 3 is half of y minus 2 plus 7y plus 6, okay? If you want to not deal with the fraction, then instead you could multiply everything by 2 here and say that 2 5y minus 3's would equal the sum, y minus 2 plus 7y plus 6. Then you don't have to deal with fractions and everybody's happier. Distribute and group your like terms. You have 10y minus 6 equals, I have 8y's, and then I have minus 2 plus 6 giving me plus 4. Subtracting 8y from both sides. I presume if Mr. Shaw disagrees, he'll clear his throat or something. Plus 6. So I have 2y equals 10, so y equals 5. How'd it go? Good? Okay. All right. 2 more of these, and then we'll do kites. Done is an isosceles trapezoid. It says that the measure of angle EDO is 110. So this is 110. It says the measure of angle DEN is 15x minus 5. Find the value of x. Well, these are just supplementary angles. They're same side interior angles. I'm looking at the letters right now. Okay, so I have 110 plus 15x minus 5 equals 180. A quicker way to do this, if you are thinking, if these are supplementary and that's 110, that's got to be 70. You could just set that equal to 170 and go with that. So I'm going to do that. I'm just going to subtract 110 from both sides starting off. And say that this is going to equal 70 to make my numbers a little bit smaller. So adding 5 to both sides, I have 15x equals 75. 15x equals 75, so x equals 5. Excellent. Okay, one more of these. Trap is an isosceles trapezoid. We have that PR is 3x minus 7, and TA is 20. Well, in an isosceles trapezoid, the diagonals are congruent, so we're just going to set those equal to each other, and 3x minus 7 equals 20. Adding 7 to both sides, I have 3x equals 27. Again, presuming you know your times tables, we know that x there equals 9. Hopefully we're okay so far. I know I went quickly, but also know that you have a pause button. Kites are on the back. There are some qualities that I laid out here. Now, I wrote in 4 of them, so take the time, please, to write in that they are perpendicular bisectors, one pair of congruent angles. The long diagonal bisects the short diagonal, and the long diagonal bisects the angles that it hits. And I've indicated all of this here, so please take the time to do that. And there's an example here with no questions, so I'm assuming that they want you to find all those angle measures, okay? All right, so the diagonals are perpendicular, so we know that angles 1, 2, 3, and 4 are 90 degrees. We also know that the long diagonal bisects its angles, so angle 6 is also 30. And we know that angle 5 is also 40. So this is now just a triangle sum theorem. The 2 acute angles in any right triangle must add up to 90, so angle 7 must be 60, 9 must be 60, and then 10 must be 50, and 8 must be 50. All right? Okay, so once you finish this packet, and I'll show you this, I have stickers for this. Once you have finished this booklet, you are to finish all of the IXL. These are the IXL skills for Chapter 6 or Topic 6 that we assigned prior to the Thanksgiving break. So hopefully you've got a good jump on them, but these are due next class at the beginning before the test. Also, the Chapter 6 test and notebook check is next class. Please feel free to email us or ask us if we're sitting right in front of you. if you have any questions. Good luck.